Hi, we're Team GCRC. I'm Jarrett.
I'm Mike.
I'm Pavel.
And I'm Matt.
Seen below is the track component of our project, GCRC. It's broken down into three pieces: the keyboard, the LCD, and an ultrasonic sensor. The keyboard is used for user entry and to start a new game. Basically, the keyboard works as a resistor field input on GPIO pins in a SmartFusion. The output of this is driven directly to the LCD for a username, which is done over SPI. If we were to enter in a new user, we could enter 4 digits into the LCD. That will be the 4 digits that we entered. We hit the pound key to send the signal that the user is ready. Now, once the game is ready to start, we go over to the LCD. Since we just broke the LCD with the camera, we should be on lap number 1. If you go back to the LCD, you can see lap 1. Now, shown below is the right side of the vest, the controller of the RC car. On the left, we have a button that is used strictly to say that we are going to start sending signal now, or we are going to stop sending signal to the car. On the right, the true controller of the vehicle has 4 directions: forward, backward, right, and left. When these directions are used on an accelerometer, it'll send a voltage. We read that voltage using an ADC, and then from there, we take and create a forward and backward state with 0 to 15 as the actual speed value for both the right and the left side of the vehicle.
We send a signal through the UART port and we then transmit the signal through the ZigBee. We have the receiving ZigBee in the car, and it's also attached to the UART port. We have interrupts to know when we receive a signal. So whenever we receive a signal, we enable the interrupt, and then the new value that came in would be directly transferred into the PWM, and we will have the new speed and direction of the car based on the new value. And the way we do it, based on the 32 states for each side of the car, we transfer these 32 states into the 32 distinctive PWMs for each side of the car, and that's how we can turn, we can go forward, we can go backwards. It allows us to do pretty. This allows us to have a continuous control of the speed of the car. And the way we control the speed of the car, we use the dual H-bridge, which controls each side of the car. Two motors are hooked up to each side of the H-bridge, and it outputs, based on the PWM that it receives, it outputs a certain voltage to powering the motors.
Basically, I'm going to flex my left bicep. This light will go off for boost mode. This signal will go up saying that my muscle is flexed, and you can also see it on the oscilloscope here. It'll happen right now. Notice the light goes off, we boost for 2 seconds. The light starts blinking now, which means it's recharging. It'll go full now. I can flex again. Show you some more flexing. You can look at the oscilloscope. Let's let it calm down. And we'll go flex, hold, and then we will release. And then flex, flex, flex.
Drive.